Data sampling techniques. Introduction to data sampling techniques. Data means collection of information or measurements or observations. Sample is a small group of members selected from population to represent the population subset of population. Population means groups from which sample is drawn to exact population will depend on the scope of the study. Technique means a particular method of doing activity is called technique. Data sampling techniques refers to the various methods used to select representative subsets from a large dataset or population. These techniques play a critical role in the data science, machine learning, and statistical analysis, where accurate predictions or decisions needed to be made without always processing the full data. Types of data sampling techniques. Two types: probability sampling technique, non-probability sampling technique. Probability sampling is a technique where every member of the population has a known and equal chance of being selected in the sample. This method is random unbiased, which means sample is more likely to be representative of whole population. Types: simple random sampling, systematic sampling, stratified sampling, cluster sampling. Next, non-probability sampling. Non-probability sampling, not every member of population has chance of being selected. This selection is often subjective or based on consequence, not randomness. Types of non-probability sampling techniques: convenience sampling, judgmental sampling, quanta sampling, snowball sampling. Why did I choose this project? Sampling technique helps to reduce dataset size while maintaining the data integrity for for faster efficient analysis. This project highlights how effective sampling boosts models performance and lower computational cost in the real world application. Formulas used for solving numericals. Sample mean x bar equal to 1 by n into summation of I equal to 1 to n xi. Sample variance s square equal to 1 by n minus 1 into summation of I equal to 1 to n xi minus x bar whole square. Standard deviation equal to root s square. Stratified sampling mean x bar equal to summation of I equal to 1 to k n of I, capital N of I, xi bar by summation of I equal to 1 to k n of I. N of I is the size of the stratium. Xi is the mean of stratium I. Systematic sampling size k equal to capital N by small n. Capital N is the population size. Small n is the sample size. Margin of error equal to z into s by root n. Sample size for proportions n equal to z square into p into 1 minus p by e square. Problem statement: you have a data set 1000 retail transactions. Due to time and computational limitations, you need to analyze a sample of 10% of data. Let's apply and compare few sampling techniques to extract 100 samples. First, we need to take random sampling. Select the 100 records randomly at the data from the data set, capital N equal to 100. Systematic sampling. Select every 10th record. Systematic sampling formula K equal to total by capital N. Total 1000 by N. N means number of samples. 100. 1000 by 100 equal to 10. Start at random position between 1 to 10. Stratified sampling. Divided data into strata. Sample proportionality for each category. Conclusion. Use random sampling for general analysis. Use stratified sampling when subgroup balance is essential. Use systematic sampling for efficiency when data is ordered. Advantages of data sampling technique: faster process, maintain accuracy, simple complex data, effective for real-time systems, improve model training, support for statistical interference, enable analysis for big data. These are the advantages of data sampling techniques. Disadvantages of data sampling techniques: loss of data details, less accuracy than full data, possibility of sampling errors, complex selection process, sampling bias. These are the disadvantages of the data sampling techniques. Comparison: data sampling versus other algorithm techniques. Techniques approach best for scalability. Technique: data sampling approach, select subset of best select subset of data best for fast training and big data. Scalability is high. Smart means oversampling technique that generates synthetic samples from the minority class. This called smart. This is called smart. Approach: add the synthetic minority samples, best for class imbalance. Scalability is moderated. Data cleaning, remove the errors, best for data quality and pre-processing. Scalability is high. Feature selection, choose the key features, best for improve the accuracy and reduce the overfit. Scalability is good. PCA approach: reduce the future dimensions, best for high dimensional data. Scalability medium to low. Normalization, group similar data, faster finding and segmentations. Scalability is very high. Data augmentation, create the new data, best for deep learning and vision task. Scalability is medium. Real world application: market survey, healthcare research, and election polls. These all sampling to draw the insights from small group, enabling informed decisions without analyzing entire population. These examples how sampling save time and resources while maintaining the result accuracy. Conclusion: data sampling techniques enables efficient analysis of a large data sets by reducing time, cost, and resources while maintaining accuracy. By selecting methods like random, stratified, or clustering sampling analysis to ensure the representative results across the real world applications. Thank you.
Recording in progress.